Hello, everyone, and welcome. I am Zoe, a member of the ICCT communications team. Thank you so much for attending today's webinar. This webinar is being recorded, as you heard, and it will be available on our YouTube channel in the coming weeks. Everyone has their microphones on mute. If you have questions, you can write them in the questions block in the control panel to the right of your screen. After the presentation, that will last about 20 minutes, we will have an additional 10 to 15 minutes to answer questions from the audience. Today, we are going to talk about, can fuel cell hydrogen trucks ever be cost effective? The European case, presented by Hussein Basma. Hussein is an associate researcher in the heavy duty vehicles program at ICCT. But before presenting Hussein, I would like to introduce Felipe Rodríguez, the lead of our heavy duty vehicles program at ICCT.
Thank you, Zoe, and welcome everybody to our webinar on the cost effectiveness of fuel cell trucks in decarbonizing the heavy-duty sector in Europe. I would like to introduce briefly the ICCT to begin with. So the ICCT is a non-profit research organization with an international footprint that works to improve the environmental performance of motor vehicles. That's all types of transportation, going from two-wheelers to cars, trucks, planes, and ships. While the ICCT was initially born to address pollutant emissions from engines, from combustion engines, we have more recently transitioned to perform all type of analysis, technology and economic analysis on the feasibility to fully electrify the transportation sector by mid-century. Next slide, please. So this is in line with what we see is necessary to be able to achieve the Paris agreements and achieve that under 2 degrees Celsius of global warming by mid-century. So I want to walk you through this wedge diagram to get across the magnitude of the challenge that we're facing right now. So the top line of that diagram is the baseline projection of CO2 emissions, transport CO2 emissions out to 2050. And what we see is that under currently adopted policies, transportation emissions are going to continue increasing out to mid-century. So we need to do more, of course. The next wedge that you see there in purple are proposed regulations in the leading markets that we work with, many of those represented in the CEF Transition Council, a group of which the ICCT serves as the secretariat. And we see that many proposals offset a lot of the emissions that are going to occur by mid-century, but that is definitely not necessary. So more needs to be done, not only in the leading economies, but also in emerging markets. And something that I want to highlight and for you to remember is that the contribution of the light-duty vehicle sector and the heavy-duty vehicle sector to achieve that decarbonization is roughly equal. So while the discussion on the public light tends to focus on passenger cars, we see that trucks are as important in the decarbonization of the transport sector out to mid-century. And if we implement all of these accelerated CEF transition policies, we can get on a pathway that is compliant with that 2 degrees or under 2 degrees of global warming by mid-century. So I wanted to set this context to highlight that the research that Hussein is going to present today takes a look at one element of that equation. So what is going to be the demand of this type of freight vehicles, and how can they contribute to this transition? So this is a techno-economic assessment of a given technology pathway, a given technology option, and it is not meant right now as a comparison between technologies, but just to understand better if and how can fuel cell trucks powered by green hydrogen contribute in this transition. So without further ado, I'm just going to hand it over to Hussein, who's going to present the analysis that he conducted.
Thank you, Felipe. So yeah, as Felipe mentioned, today we will be talking about hydrogen fuel cell trucks in Europe. And the outline of this presentation is as follows. So first, I will start with a technology analysis for fuel cell trucks, mainly operating in long haul, one of the most important and challenging segments to decarbonize in the EU. And the next part of the presentation will talk about the economic analysis of fuel cell trucks, which mainly would cover the total cost of ownership of these trucks. And finally, we will conclude with the main findings of this webinar. So starting with the technology analysis part of the presentation, the scope mainly here is to try to quantify some key operational metrics for fuel cell trucks, mainly their fuel economy, their driving range, their payload capacity. And also we would like to compare the energy efficiency of fuel cell trucks to other currently available powertrain technologies. The findings and the results of these slides are already available on the published report on our website, and you can access that through the link below in this slide. So first, a couple of words about the methods and the modeling approach that we adopt in order to quantify the fuel economy of fuel cell trucks in the EU, so their hydrogen consumption. We do that by implementing a comprehensive vehicle energy consumption modeling, where we focus on the main fuel cell truck powertrain components, such as the fuel cell stack, the battery pack, the power electronics, and the controllers for the powertrain, in addition to the vehicle longitudinal dynamics. We also take into account the consumption of the thermal auxiliaries, such as the battery cooling and heating needs, and also the truck cabin cooling and heating needs. So more details about the inputs, assumptions, and data are available in the report. I will jump in directly into the more interesting part about the results. So in this slide, I'm showing the hydrogen fuel consumption for fuel cell trucks operating in long haul, so over the Vecto long haul cycle at a specific payload, which is the reference payload of 19.3 tons. So at these operating conditions, the hydrogen consumption of fuel cell trucks today is in the range of 9 kilograms per 100 kilometers. This number has the potential to decrease to roughly 6.64, 6.5 euros per kilograms per 100 kilometer a decade from now. And mainly this would be driven by the expected improvement in the truck technology, such as the aerodynamics of the truck, the rolling resistance, the chassis material lightweighting, also the fuel cell pack efficiency, and also the drivetrain efficiency in general. So we may achieve up to 30% fuel economy improvement. Well, these fuel economy numbers would actually give us an idea of what would be the needed hydrogen storage capacity on board in order to drive a certain mileage. So for example, on the right-hand side of the slide, I show that we would need something in the range of 45 kilograms of usable hydrogen capacity on board today to drive 500 kilometers, which is a typical driving mileage for long-haul trucks in the EU. If you want to drive even more than that, so up to 1,000 kilometers, we would need something in the range of 90 kilograms, which is a number slightly higher than most of the currently commercially available or announced fuel cell truck models in the EU. Nonetheless, with the improvement in the fuel economy, we would need definitely less hydrogen storage capacity on board to drive these same driving ranges. Moving now to another very important aspect when it comes to fuel cell trucks, which is their storage capacity. So fuel cell trucks actually can only store so much hydrogen tanks on board because there are some geometric constraints and volume constraints as well on board the trucks. So the most, I would say, typical design for the hydrogen storage tanks is, as you can see on the right-hand side of the slide. So these are either installed at the back of the truck's cabin, so these are mainly compressed gas hydrogen storage system, or for the liquid hydrogen storage tanks, these will be installed along the wheelbase of the truck or on the sides of the truck. And through a global geometric approach, we calculate the maximum allowable storage volume given all these geometric constraints of the trucks. And the thing is, different hydrogen storage techniques would actually result in different storage capacities and different driving ranges. So for example, in the case of the 350 bar hydrogen storage technology, we can only store up to 35 kilograms on board given the volume constraints. And this would actually allow us to drive something in the range of 350 to less than 400 kilometers. However, if we move to liquid hydrogen storage, which is a storage system with higher energy density, we can store up to 75 kilograms of hydrogen, usable hydrogen on board, which will allow us to drive something in the range of 800 kilometers today. Definitely these ranges would improve as the technology also improves by the end of the decade. Another important aspect when it comes to long-haul trucks in specific is their payload capacity. So fuel cell trucks in general are not expected to have any payload penalty relative to diesel. So we expect them to have a similar payload capacity. Unlike battery electric trucks, which I show here in this blue line, battery electric trucks would actually have some payload losses, especially for high driving ranges, where we would need to install big batteries on board to cover these mile ranges. Nonetheless, improvements in the battery energy density and also the battery and the energy efficiency of the truck would actually reduce significantly this payload capacity losses for electric trucks. So fuel cell trucks are not expected to have a payload capacity loss from a gross vehicle weight perspective. Nonetheless, fuel cell trucks actually may suffer from axle load constraints. And as a basic illustration on the right-hand side of the slide, I am showing here that in the bottom figure, that if we install hydrogen tanks on board, mainly at the back of the truck's cabin, this would actually push the position of the fifth wheel backwards. So this will make it closer to the rear axle. And in other words, this would increase the axle load on the drive axle here at the back. And this would actually result in payload capacity losses. We roughly estimate these payload capacity losses to be something in the range of 10 to 15% relative to diesel trucks. So that's about the payload capacity of these trucks. And finally, for the technology analysis part of this webinar, I will be showing here, I'm showing the energy efficiency comparison between the diesel fuel cells and also the battery electric truck technologies. So for the fuel cell trucks, so for all technologies, I am comparing their electricity equivalent energy consumptions measured in kilowatt hours per kilometer. And this is calculated at the energy storage level. So this is the tank to wheel energy consumption. So fuel cell trucks, these red bars, could actually provide something in the range of 10 to 15% enhancement in energy efficiency relative to diesel trucks, while battery electric trucks would still remain the most energy efficient technology, achieving something in the range of 60% more energy efficiency than diesel trucks. This relatively limited enhancement in energy efficiency for the fuel cell technologies is actually mainly driven by the fuel cell stack, more like thermodynamic limits. So the peak efficiency of a fuel cell stack today is 60%, expected definitely to improve over in the future, reaching 65, 67% as a peak efficiency, which is not significantly higher than the peak efficiency of best-in-class diesel internal combustion engines today, around 46%, maybe 47%. So this explains the limited energy efficiency improvement for the fuel cell trucks in this case. So that's about it for the technology analysis part of the webinar. I will now move to talk about the economic part, where I will be talking about the total cost of ownership, abbreviated as TCO in this webinar, in this study. Again, focusing on fuel cell trucks operating in long haul. The geographic scope of this study covers 7 European countries. And the idea is we try to quantify the TCO of fuel cell trucks and compare that to diesel trucks. And then we will try to examine the impact of several policy measures and how such policies would actually affect or reduce the TCO gap, if any, between fuel cell trucks and their diesel counterparts. And also all the slides and the results of this part of the presentation are available on our recently published report on our website through the link below. So first, a couple of words about the TCO methods that we use. So we try to be as comprehensive as possible here. For for the TCO calculation, we look at the investment cost, mainly the purchase price of the fuel cell trucks and the diesel trucks. We definitely look at the energy and fuel costs, so the diesel and the hydrogen fuel cost, maintenance cost, infrastructure cost in the case of hydrogen, also taxes, tolls, and other country-specific costs. Moving to some intermediate results first. So in this slide, I am showing the two main cost components of the TCO, the retail price of the trucks and then the fuel price, which is the hydrogen fuel price in this case. So starting with the retail price of the trucks. So as you can see here in the left-hand side of the slide, the retail price difference between the fuel cell and the diesel truck is significant. Today, we estimate this to be more than 200K for the long-haul trucks of interest in this study. So this is like 200%, 250% more than the diesel truck. But we do expect that these prices would actually decrease mainly by the end of the decade, and the retail price gap would become something in the range of 50,000 euros or 30% more expensive than their diesel equivalent. And this behavior will be mainly driven by the reduction in the fuel cell units costs. When it comes to the fuel prices, so we actually model the price of green hydrogen, so hydrogen produced from renewable electrolysis in the EU, and we only consider locally produced hydrogen in the countries of interest through decentralized production. And as you can see, for example, in the case of Germany, today green hydrogen price would be in the range of 11 euros per kilogram. And then by 2030, by 2035, we project that this have the potential to decrease to 8 to 9 euros per kilogram. And for other countries, we would witness different prices driven by the country-specific renewable electricity cost and other country-specific cost components. So that being said, I will now move to the TCO results of this analysis. And in this slide, I'm showing the TCO of the fuel cell trucks and the diesel trucks for 4 different European countries. The general trend here is that the TCO of the fuel cell trucks continuously decrease over the next decade. So the TCO gap is significant in 2022, but it will be less by 2030. For example, in the case of France, the TCO, so fuel cell trucks would be 15 to 20% more expensive in TCO relative to diesel. In Germany, this number is slightly higher. The gap is higher. It's roughly 30% more expensive in a TCO from a TCO perspective. In the Netherlands, it's a more positive case where the TCO is roughly 10% higher than their diesel counterparts. And the reason we have a decreasing TCO for the fuel cell trucks is, so as I've shown on the previous slide, we have a reduced retail price by the end of the decade. We also have reduction in the green hydrogen price by 2030, plus the improvement in the fuel cell energy efficiency, which we quantify to be something in the range of 25 to 30%. All these factors combined are leading to this reduced TCO by 2030 relative to 2022 for fuel cell trucks. But the main point would still be that fuel cell trucks would still have a higher TCO relative to diesel trucks even by 2030. So that being said, it would be interesting to have a closer look at this TCO breakdown to pretty much understand what is driving this TCO behavior for fuel cell trucks. And in this slide, I'm showcasing Germany. And as you can see, for example, for the 2022 data in this slide, the fuel cell truck cost, so this is the retail price, the dark gray part of the stacked bars. The fuel cell truck cost is definitely higher than the diesel truck cost, but also the operational expenses of the fuel cell trucks, mainly the fuel cost, these orange part of the bars, are also significantly higher than their diesel counterparts. So the capital investment is higher for fuel cell trucks, and also the operational expenses are higher. If we look at 2030, in the 2030 scenario, so the fuel cell truck cost, so the retail price of the truck would be close to its diesel counterpart, But still, the operational expenses, mainly the fuel cost, will still be significantly higher, something in the range of 1.8 times to 2 times higher than diesel trucks. So even if the retail price of both technologies converge to the same range, fuel cell trucks are more expensive to operate, which will make their TCO higher as well. So that being said, since fuel cell trucks are more expensive to operate based on these fuel prices projections, the question remains, what would be the needed hydrogen price that would allow fuel cell trucks to achieve TCO parity with diesel trucks? Or in other words, what is the break-even hydrogen price at the pump that we need for both technologies to become pretty much the same in terms of TCO? And that's what we calculate, and I summarize these numbers on this map. In the case of Germany, as you can see, we would need a break-even price for hydrogen, for green hydrogen, around 4.2 euros per kilogram. In the United Kingdom, we need something in around 5 euros per kilogram. In Poland, it's even more severe. We need 3.5 euros per kilogram. A lower break-even price here implies that it is more expensive to transition to fuel cell trucks. So it is more difficult to switch to fuel cell trucks. And if we compare these break-even hydrogen prices that we need to the expected hydrogen prices by the end of the decade, we can see there is a significant difference here between both prices. So again, in the case of Germany, the break-even price, as you can see here in the light blue bars, is something around 4.2 euros per kilogram. But the expected price by then is around 8.5 euros per kilogram. So there is a gap of around 50% or 4-point-something euros per kilogram for fuel cell trucks operating in Germany. And this is a significant gap. In other words, if fuel cell trucks are to become cost competitive with diesel trucks, that's how much we should subsidize the use of green hydrogen at the pump. And it is yet not clear if such level of subsidies will be implementable in the EU. So in addition to subsidizing the use of green hydrogen, other policy measures and interventions can actually reduce the TCO gap between fuel cell trucks and their diesel equivalents. For example, out of these policies, we looked at purchase incentives, road tolls exemption for zero emission trucks, so for fuel cell trucks in this case, or even CO2 external costs like road charges that reflect the CO2 cost for polluting vehicles, which is diesel trucks in this study. So all these policy measures would definitely reduce the TCO gap, but still subsidizing the hydrogen cost or the hydrogen price at the pump would remain the most influential policy measure on the TCO gap, since the TCO of fuel cell trucks will be mainly driven by the price of hydrogen at the pump in the future. So that being said, I can now move to the last section of this webinar, which is the conclusions and the main findings. So from the technology perspective, fuel cell trucks operating in long haul today consume something in the range of 9 kilograms per 100 kilometer of hydrogen fuel. And this has the potential to decrease to 6.5 kilograms by 2030. So that's something in the range of 25 to 30% reduction. We identify liquid hydrogen as a more suitable onboard storage technologies, especially for long haul trucks and for trucks driving high driving mileages reaching 1,000 kilometers, and that also have limited access to refueling stations. From an energy efficiency perspective, fuel cell trucks can provide 10 to 15% more enhancement in energy efficiency relative to diesel. And from a payload perspective, fuel cell trucks are not expected to have payload penalty relative to diesel trucks from a gross vehicle weight perspective, but still they may face axle load limitations or constraints which would eventually reduce their payload capacity. As for the economic analysis, we have seen that fuel cell trucks operating in long haul would need some significant policy support to reach cost parity, TCO parity by the end of the decade with diesel trucks. And we have seen that the price of hydrogen fuel will be the primary driver for the TCO of fuel cell electric trucks. We calculate a break-even hydrogen price in the range of 3 to 5 euros per kilogram, depending on the European country of interest in this study. So we would need hydrogen price to be in this range in order to achieve TCO parity by the end of the decade between fuel cells and diesel trucks. And finally, we conclude that hydrogen fuel subsidies are likely necessary if fuel cell trucks are to become economically viable relative to diesel trucks, at least until 2035, 2040. So that's it from my side. Thank you for your time. I'm looking forward to your questions.
You're on mute.
Yep. Thank you so much, Hussein. That was a great presentation. And thank you to Felipe for your really insightful introduction. We will now move on to our Q&A section of the webinar. Remember, please, if you have questions, write them in the questions box in your control panel, and we'll get to as many as we can. We've already had a couple come in, and if we don't get to your questions today, we can try and connect with you via email later. So, starting off, first question here. Do you expect the EU's new Hydrogen Bank initiative to have significant impact on the TCO of fuel cell?
So for the in the end, it all comes down to the price of hydrogen at the pump that we're going to have. So regardless of the impact of different policy measures that we might have in the future, the point is, if we can achieve these hydrogen fuel prices at the pump, then fuel cell trucks would definitely become cost competitive with diesel trucks.
Great, thank you. Next question. Did you consider different costs in FCEV purchase price for different H2 storage? How much did you find this varied from gas to liquid?
So yeah, so when we estimated the retail price of these fuel cell trucks, we actually looked at the 700 bar storage technology cost. We believe 700 bar is already technology that is mature enough for long-haul trucks. Nonetheless, it would have been interesting to examine liquid hydrogen storage cost as well, but due to lack of data availability, we couldn't actually provide some solid cost estimates for liquid hydrogen storage systems.
Wonderful, thank you. Fun question here, I like this one. Comparing this analysis with your battery electric truck analysis shows hydrogen is much more expensive. Is there any place for hydrogen?
Well, so the scope of this presentation, as we mentioned in the beginning, is to compare fuel cell trucks with diesel trucks directly. In future studies, we will be comparing both zero emission technologies, the fuel cell and the battery electric trucks, for different truck segments and different mission profiles. But I would say the main conclusion is that yes, battery electric trucks do have a TCO advantage for most of the trucking applications in the EU. Nonetheless, fuel cell trucks have some operational advantages, such as extended driving mileage and also in some cases a higher payload capacity. But to provide some very solid conclusions on this, I prefer to keep it for our next report, which we're planning to publish soon in the next couple of months.
Awesome, thank you. One more here. Given the extreme technological challenges related to the supply and use of liquid H2, how likely do you think it is that LH2 trucks will actually be developed?
Sorry, come again?
Yes. So given the extreme technological challenges related to the supply and use of liquid H2, how likely do you think it is that these kinds of trucks will actually be developed?
Well, so we have some big players in the European market, like for example Daimler. They have already announced that they will commercialize a fuel cell truck operating on liquid hydrogen as early as the second half of the decade. So in this case, I guess OEMs would be the most reliable source to follow when it comes to the technology development and enhancement. And yeah, we see that's possible. Yeah, so plus for long-haul trucks, we believe these liquid hydrogen technologies would be the most suitable ones because of the needed higher energy density for the storage system in order to have an extended driving range.
Felipe, did you want to add on?
Yes, so I just wanted to say that it is indeed some technology uncertainty about the storage and refueling pathway that fuel cell trucks will have, and we do see some challenges having both a compressed 700 bar and liquid hydrogen infrastructure coexisting due to the fact that that infrastructure will pay off and will be a profitable investment if it is used at high rates, basically if it has high utilization. So that's the biggest challenge that we have, but from the transportation perspective, we do think that if an international trade of liquid hydrogen is to develop, most of the inland transportation of hydrogen will be done in liquid form by trailers and tankers and on the roads. So we don't see the transportation of hydrogen as the main impediment for this technology to move forward, but it is more about the coexistence of those two types of infrastructure.
Thank you. I think we have time for about one more question. I want to be respectful of everyone's time today. But though if we did not get to your question, we will try to follow up with you via email. We have all of them listed here, so we'll try and get back to you. Last question is, understanding that this analysis was done for Europe and many findings would also apply in North America, do you believe that there could be any large differences if you were also to do this analysis there?
So yeah, I mean, the North American market would have some differences. Mainly the emission profiles, I would say, of trucks. So usually trucks in the US cover higher mileages than the EU. Also, the structure of the fuel price, like diesel price in the US, could be slightly less than European case. So you have many factors and many differences here that would actually play into the final TCO of fuel cell trucks in the US or in the EU. But nonetheless, there are already some other studies that have examined the cost effectiveness of fuel cell trucks in the US, and I wouldn't expect to have some drastic differences in terms of conclusions. Yeah.
And from the technology perspective, there's an important difference. In Europe, the total length of the truck is regulated quite stringently. In the US, the length of the trailer is what is regulated. So trucks can be longer, therefore having more space to accommodate for the hydrogen storage. So there will be less of a constraint, as Hussein explained today, on that regard, and also regarding the axle load, provided that trucks in the US have a 6x4 configuration, axle configuration most typically. That means that axle load can be less of an issue in the US. So from the technology perspective, I think it is a bit simpler there to achieve these long ranges with fuel cell trucks as it will be in Europe.
That's really interesting. Thank you. I'm afraid we have run out of time for questions, but thank you all so much for submitting them. We have them and we will try and get back to you. Thank you so much for participating today. Please don't hesitate to reach out to us if you have any further questions. You can go to our website and use the contact form. And I think, Hussein, you provided your email, so you can also reach Hussein there. And remember to follow us at the ICCT. And thanks again, and we hope to see you soon.